Okay, welcome everyone. Today we are going to discuss about compaction of soil. So let's start. Topic of discussion that what is compaction and how its function, uh, the effect of the compaction of the soil, the advantage of the compaction, and what are the test method. Though this is not important for now. Okay. So what do you mean by compaction? The compaction can be said as a process which is uh, which densifies the soil particles. As we know that the soil particles soil mass, total soil mass is consist of small particles, and there are air voids between the particles. Also, there may be water molecules or presence of water. So the compaction is a process by which we compact that soil particles to form a denser mass. Okay, that's its unit weight will be higher. So what are the function of the compaction? কেন এটা লাগে? uh, we have seen that in case of road or in art dam or in landfills, there are huge amount of soil is used. So if that soil mass is with voids, okay, if the voids is present in that soil mass in art dam, suppose in the art dam or the railway embankment, after certain time the embankment will settle, or the art dam, that through that void the water will pass through. So before constructing the structure, that soil must must be of certain properties so that it can sustain the requirements for that project, or for its working condition. In one word, that it is desirable that soil possesses the certain properties that it can fulfill functions. Okay, যাতে সয়েলটা অ্যাটলিস্ট মানে যে কাজের জন্য বানানো হচ্ছে সেইটা যেন ও ফুলফিল করে। যেমন আর্টজামের ক্ষেত্রেও, আর্টজামের ক্ষেত্রে যেন ওটা জল পাস না করে, বা এমব্যাঙ্কমেন্টের ক্ষেত্রে যেন সেটেল না হয়, সেই কারণে আমরা কম্প্যাকশনটা করছি। ওকে, so this is the purpose, that to prepare the soil mass suitable for certain work project having proper physical properties, যেন সার্টেন প্রপার্টিস যেন ওই সয়েলটার মধ্যে থাকে যখন আমরা ওটাকে স্ট্রাকচারটার জন্য ইউজ করব। ওকে, ক্লিয়ার না এটুকুনি? ওকে, সো let's see about its definition. What is the definition? So compaction can be defined as that a process, okay, by which its unit weight is increasing by application of mechanical energy, okay, and its void ratio is reducing. Okay, so compaction is a process of increasing the unit weight of the soil mass by reducing its air void by applying mechanical energy. Okay, clear? Okay. uh, so what are the effects of the compaction? In soil, the shear stress of the soil, I don't know if you have heard of the term shear stress. Shear stress is the property that which determine the strength of the soil. Okay, there are two parameters. One is shear strength and the one is settlement, which uh, indicates the strength of the soil. Okay, and there are shear strength there are two parameters, one is c and one is y. C is the cohesion of the soil, and phi is the internal friction angle. Okay, so here, uh, if the shear strength is higher, then it is said that the soil is stronger. So by compaction, we increase the shear strength of the soil, because as we compacting the soil particles are getting closer, okay, denser. So the friction between the soil particles, it is getting increased. That's why the shear strength is increasing. Okay, another effect is reduction of the compressibility. So what happens uh, when we are compacting the soil? The void ratio, it is getting reduced, right? So as the void ratio is reducing, so after compaction, when we are applying the load, there is not uh, much space for settlement, right? Because the voids are already reduced, right? So this is the one, another one effect, the reduction of the compressibility. Another one is reduction of the permeability. As we said before, that in case of dam, if the pore pore or void between the soil is less, then water would not pass through. Okay, so another effect of the compaction is reduction of the permeability. So we can say that compaction, it should fulfill two basic criteria. One is reduce settlement, another one is increase shear strength. Okay, these factors, or these two criteria, mainly determines the strength of the soil. So compaction should improve these two factor. Okay, that's why we are doing the compaction. Okay, uh, what is the advantage of compaction? Compaction কি সুবিধা আমাদের? Okay, let's see. Reduction of the settlement as the soil strength increased. As we have seen that soil, due to compaction, soil strength or shear strength is increasing because of the compacted soil mass. Okay, so now it is more stronger soil. So uh, because its shear strength is increased, so that's why when we are applying the load, it settles lesser. Okay, that's why reduction of settlement is occurring, because the strength of the soil is now is much higher than the before the compacted state. uh, Another one is increased soil stability due to improved strength of the soil mass. Okay, as the strength of the soil is increased, obviously the soil is stronger and it is more stable than before. Improved load bearing capacity, because of shear strength is increased, it is more stable. So improve load bearing capacity of the pavement or subgrade due to compacted soil mass. Okay, another one advantage. Okay, the last one is undesirable changes in soil volume. What is that? Uh, have you heard the term frosting or soiling? Oh, the frosting is, suppose in case of chilly area or cold area, if the if the water is present between the air voids or soil voids, water is present between in the soil mass due to the cold environment, the water freezes. Okay, it becomes ice, and as we know, the ice becomes more in volume when we when the water becomes ice. Okay, the volume of the ice is greater than that amount of water. So what happens if the water in the pore of the soil becomes if it is freezes, so it applies the pressure on the soil because it is now of higher volume. So this thing is called frosting. And what is soiling? Soiling is due to application of the water or addition of the water, soil mass, soil volume changes. Its volume increases. Okay. So these two factors, it is not suitable for if any structure. Okay, there will be settlement or there will be undesirable undulation. Okay, so these changes can be controlled by compaction. Okay, so these are the advantages of compaction. Okay, now let's get into some basic things. See, if we have said that soil is soil is made of soil particles or solid particles, water particles, and there are some air bubbles. So we can represent the soil mass like this. Okay, that is soil particles, water, and air. Uh, the weight of the water solid is ms, weight of the water is mw, volume of the water is air is va, volume of the water is bw, volume of the solid is bs. And this air and water, the total volume of air and water, it is called volume of voids. Okay, so as we have told before, during the compaction we are applying mechanical energy, right? And the mechanical energy, it's expulses the air present in the void. Okay, so what happens is that uh, we are applying the load or the external mechanical energy, and due to that the air voids are reducing. Okay, but 100% of the removal of air, 100% removal, it is not possible. Okay, so there must be in compacted state, there will be always that these three things are present, that solid, air, and water. So that's why, as what is a saturated state, if the all air voids are totally filled with water particles. But in this case, what is happening, there are some air voids which are not saturated, there are which are not filled by water. So this is partially saturated, and the compacted soil stress is always will be in the partially saturated state. Okay, clear? uh, so now we have seen what is compaction, what is its advantage, what is the effect. Now we have to measure the compaction or its factors or something, right? What is happening by compaction, we have to measure that, right? So there, for that there are two theories, and for that, from that theories, there are some tests which are conducted in the laboratory. Okay, so two types of tests are there. One is standard Proctor test, another one is modified Proctor test. So we will now just discuss the standard Proctor test, okay, because it is the commonly uh, it is generally done in the field. Okay. uh, you see this is called Proctor mold. Okay, these are the dimensions. So what, and this is called hammer. The weight of the hammer is 2.5 kg. Okay, so these are the diameter and dimensions. Okay, so what happened during the test is that uh, 5 kg of soil, dry soil, is taken and mixed with some amount of water. Okay, so after mixing, you keep that. Okay, and this is called base plate. This lower portion is base plate, and this is called mold, and this is called collar. So uh, this mold and this base plate, it is weighted. Okay, its weight is taken, and after taking without this collar. Okay, the collar will not be attached during the weight, while we are taking the weight of the mold and the base plate. So after measuring that weight, we the mixed soil, okay, we put into this mold. Okay, with three layer. The required thing is that we'll fill this mold with that soil in three layer. Okay, and after making each layer 25 blows with this hammer, the 2.5 kg hammer, is 25 blows are given in each layer. Okay, so total blows how much? 75 layer, 75 blows will be given in three layers. Okay, so after the blows has been given, this mold is filled with soil. Up to this we'll fill it, and then we will detach the we will take the weight of this thing. Okay, and as we know the dimension and this thing, this weight, we know the dimension of the mold, so we know the volume of the mold. Okay, and subtracting the total volume and this volume of base plate and the mold, we will get the volume of the that water, that soil mass or soil mixture, how much soil is has been compacted there. Okay, so that weight divided by volume, how what we will get? We will get the bulk density. Okay, so now bulk densities, we have got the bulk density. Now after measuring the bulk density, what we will do, we will take samples from this mold. Okay, from three layers we will take three sample. Okay, in container we'll take three container and we'll keep the sample. And what what why are we taking that those sample? We have to we have to measure the water content. What is the water content in this soil sample? Okay, one thing uh, I should mention, we as you have given that 75 blows, right? So you measure the total weight. So so again after taking the weight, same process will be repeated until, okay, this total weight is lesser than the previous weight. Okay, because first suppose you are taking w1, then w2 will be greater. Okay, because we are adding the water, more and more water, so is weight is getting increased. Okay, but after some time there will be a value that value will be lesser than the previous one. So that time we will stop the test, and we'll take the value of the we'll measure the value of the water contents. Okay, so now uh, from this sample which we have taken from the mold, from these three layers, we are keeping that in the oven for drying, and after 24 hours we will measure the water content. Okay, So we now got bulk density and water content. So from that, we can measure dry density, and that formula is this one: gamma d equals to gamma b by 1 plus w, right? Okay. uh, so now we are representing the result of the compaction in a graphical manner. See, in the y-axis there is dry density which we got, and there are water contents which we have added to the soil, right? And the exact water content where we are getting from, where that container uh, which we took out from these layers, right? We kept in the container and we are measuring the water content. So these water contents are plotted here. And now suppose like this type of curve will there will be this type of curve. Okay, so some point the curve will be at this point. This is the maximum value of the dry density, and at this point the value of the moisture content is called optimum moisture content. Okay, so at this point the soil is achieving the maximum density. Okay, this is called zero air void line. What happens here is that here the soil is saturated. Okay. One more thing, see here the curve is first getting increased, like, and then after it getting decreased. Why this is happening? There is explanation. See, if as we are adding the water during the compaction, first we are adding water to the soil mass, but that time the soil water particles are accumulating around the soil particles, and what happens is that the friction between the soil particles is getting lesser because of there are coating of water particles surrounding the soil. So that's why the friction of the friction between the soil particles, it become less. So that's why uh, they move easily. Okay, so that's why the the air voids between the soil particles, okay, as the friction is now lesser, the other soil particles that goes into that void, into the air void. Okay, the air void is filled by those soil particles because of the there is less friction between the soil particles. Okay, so that's why the density is increasing, because in the same volume that is occurring. Okay, in the same volume the void is getting replaced by soil particles. So the weight, solid particles weight is getting bigger, and so that's why weight by volume density will be higher. So that's why this portion of curve, and this is called dry side of the compaction curve. Okay, this is also called compaction curve, and this is called dry side of the compaction curve. And what happens in this side, why it is getting this way, decreasing? So here what is happening, the soil is already achieved maximum moisture content, a maximum density, and we are adding moisture, right? So here we are adding water in that volume. So volume of water is lesser, weight of the water or specificity of the water is lesser than soil particles. So in this constant volume we are adding water. Okay, so much now what happens in the dry side here, soil particles were replacing the air voids, but what will happen in this side, that the water particles will replace the soil particles. Okay, clear na? That side the air void is getting replaced by water soil particles, because that's why the weight is weight was getting bigger or higher. And in this side the water particles are replacing the soil particles, so that's why the density is getting lesser. Okay, this is called weight side. So this is the compaction curve. This point is called maximum density. Normally have we have to determine that value. Okay, in the compaction curve or in the compaction test, we have to generally determine the maximum density and what is the optimum moisture content. So, and this one is on another one thing you have to you can memorize it, that the total compacting effort or compaction, the total energy which is required for standard Proctor test, that is 594 kilojoule per meter cube. This is also important for that MCQ part or MCQ courses. Okay, so what we can conclude: the soil mass attains a dense state which has increased shear strength, in lesser permeability and lesser compressibility, and it achieves maximum density at optimum moisture content. Okay, okay, so thank you. Today we are finishing here. Okay.